Hey, today we're going to take some notes on determining whether a relation is a function. The other day, you watched a video about what a function is. Today, by the end of this video, we want you to be able to do a couple of tests to see if a function is actually, if a relation actually is a function. So we are going to draw all over these doodle notes to see. First, we're going to talk about tables. Review the columns to the right. See these columns? The relation will be a function if any, and excuse my writing, it's hard to write on this, x value. Okay, write with me. I'll get a little bit better at this, I promise. If any x value corresponds to more than one different y value. Okay, so I want you to imagine the last time we took notes, we talked about a function machine. If I stick something into that function machine, everything I put in there can only give me one answer. So I want you to look at this right now. If I put in -1, I get a 1. Okay, but look at this. If I put in a 1, I still get a 1. That's okay because the x values are different. I might get the same thing for everything I put in there, but I'm putting in different values, so that's okay. So circle yes, this is okay. You can highlight it, do whatever you need to. But now I want you to notice B. If I put a 3 in, I get a -6. But the next time I put a 3 in, I get a +6? Nope, that is not a function. You can't put in two different things into two of the same thing, I'm sorry. You cannot put two of the same thing in a function machine and get two different answers. That is not a function. Now we're going to talk about set notation. Review each ordered pair. The relation will not be a function if any, and this time we're going to say x, it's almost always x, this time we're going to say x coordinate. Now remember, coordinate is like a point on a graph. Okay, I'm trying to spell it the best I can using my mouse pad, so it's a little tricky. If any x coordinate corresponds to more than one different y coordinate. Oh, C-O-O-R-D-I-N-A-T-E. Sorry, this would be easier if I was on the board, but I'm not. I'm on my mouse pad. Okay, now I want you to notice a couple of things. First of all, when we talk about set notation, that's what this is called, it's when you see these brackets, and that's including a set of values. Sometimes it's not numbers. But this is a set of numbers. Notice all of the x's are different values. I'm going to, instead of circling them, I'll underline them. So if I put a 3 in, I get a 3. If I put a 2 in, I also get a 3, but that's okay. So circle y. Now notice this. If I put a 1 in, I get an 8. But this time over here, if I put a 1 in, I get a -3. That's not okay. You can't get two different answers for the same thing you put in. So that's not. So please color that in. If you need to pause the video, please do so now because I'm going to clear the screen as I scroll down. It's tricky. It's tricky. Okay, now we're going to talk about graphs. Again, this time it's actually kind of fun. If you remember when we were graphing in transformations, we talked about reflecting over an x equals line. Those x equals lines go through the x axis. Do you remember that? They look like this. They're vertical lines. So remember, we can only have one value of x for a value of y. So use the vertical, oh, I can't spell, vertical line test. Vertical line test. Please say that. Okay. Now, did you notice I already drew some vertical lines? Every time I draw a line, it should only go through one point. Okay. So if it goes through more than one point, then it's not a function. Okay, so what you need to write here too is it passes through more than one point. If it passes through more than one point, it will not be a function. So the relation will not be a function if the vertical line ever passes through, excuse my writing, I'm sorry, through, oh my gosh, more than one point. Okay, we're getting there, More than 1 point. Then, one point, sorry about that. Okay, now if you notice in letter E, all of our vertical lines pass through 1 point. So yes, it's a function. Uh-oh, look at F. Well, if I draw my vertical line, look at that one goes through 2 points. So right away, no, this is not a function. Circle the no. Now review the arrows. This is called a mapping diagram. You've probably never seen this before, but kind of think about it as it's like coupling up numbers, like they're matching numbers. So if you review the arrows, the relation will not be a function. Let's circle this so you don't forget. It will not be a function if any x value maps to more than one different y value. I mean, these are really all the same for each one of these things. So let's look at this first one. Are any of the x's the same? No, so we're probably in pretty good shape. If none of the x's are the same, it's okay if we get two of the same y values, but none of the x's should be the same. So this is good. This is a yes. Let's look at this. If I have a 3, I could get a 4, or I could get a 16. That's not okay. You can't get two different answers. So circle this. It's a no. Okay, again, if you need to pause right now because you didn't get all this stuff, do it right now because I'm going to scroll down. Oh, I forgot to mention one thing. I really need to mention this to you. Can you also go back to these two graphs right here? I'm going to make it blue this time. Did you notice that these are not straight lines? You're going to learn more about those later, but for right now, I need you to know that these are called non-linear. Both of these. Neither of them are in a straight line, so they are called non-linear. Oh, gosh. Let me fix my E for you. Notice the word line is in non-linear. Neither of these are linear, so make sure that you leave yourself a message about that because it's really important for you to recognize when lines are going to be linear and when they're not linear. These two are not linear. They're not in a straight line. Okay, scrolling down. At this point, I want you to notice these problems. It says finding domain and range. Now remember, domain is the x, range is the y. The domain is the set of all possible x values that's an E. I'm having trouble with my E's. And the range is the set of all the y values. So the domain is like where the values come from. The range is what values are possible once they're there. Now it says identify domain and range of all the relations in the table. Set notation and graph examples above. So I'm going to just start you off here. If you look up at the top at the table, we had the numbers in the y or the x column were it was -1, 0, and 1. Notice my brackets I tried to do my best of. What was the range? The range was just 1 and 0. Okay? Please continue on. I will show you my solution in a second. So for each of these in the graph, or the table, I'm sorry, I hope that you listed for A, B, C, D, E, and F all of the values we could have for the x's and their corresponding ranges, the range values. They're right here. If you need to pause the video to fill in this table, please do so, but I'm going to move on because I need to make this video just slightly quicker. So I'm going to scroll over to the right and up because I want to give you an example of this graph. Let's just try some numbers here. Let me zoom out a little bit. Sorry about that. It says create a mapping diagram and a graph that each represents functions. So I'm going to use a different color this time. I'll use blue. I'm going to just come up with 3 different numbers. 1, 0, -1, and let's say -2. And let's say in this case, I get 2, 0, -2, and -4. Notice every value I put in for x or the domain gives me a different range. So let's plot these right now. I have 1, 2, here's my dot. 0, 0, that's another place we call the origin. -1, -2, and -2, -4. Now this line I'm going to create is a little bit crazy, so do your best to use a ruler if you can, okay? Mine's going to be harder to do without a ruler. But if you notice, is this linear? Yes, it is. It's a straight line. So please write down that this is linear. It's a linear function. And yes, it is a function. If I did, let's try it right now. Let's just try the vertical line test. Look at this. If I draw vertical lines, I only go through one point. Okay, make sure you have all of these notes. Feel free to rewind the video if you need to, or pause it.